What's up everyone, and in this video, I'm going to be showing you guys how to make your own penetration testing lab. We will be using tools like Nmap and Wireshark. And don't worry, this video is made for beginners. If you guys do want to see more advanced tutorials, let me know down in the comments, and I will be more than happy to make them. Let's get right into it. Alright, we're going to start off with opening up any browser, and then we are first going to install VirtualBox. Go ahead and click this first link, click download, and then download for Windows host. Alright, once you have your VirtualBox executable, go ahead and double click it. It's going to start the installer. Go ahead and click next. Accept the terms. You can leave all of this as default, unless you want to change the default download location. Click next again, and then yes. If you get this screen right here, just go ahead and hit yes. Now for me personally, I usually like to uncheck this box because I don't like desktop shortcuts. Hit next, and then install. You can go ahead and check this, and then click finish. Now we have to download Kali Linux and Windows. Back in your browser, search up Kali Linux. Click the first link. Download. Virtual machines. From here, you're going to want to install the pre-built virtual machine for VirtualBox. While that's installing, we can go download our Windows 10 installation media. Just search up Windows 10, and then click this first link. Scroll down, and you're going to want to download the Windows 10 installation media. Download now. Once both of them finish downloading, you're going to want to first extract your Kali Linux. If you have a third-party zipping tool like WinRAR or 7-zip, I would recommend using that. If not, you can just extract all using the built-in Windows utility. For this case, I'm going to be using WinRAR. Go ahead and extract here. Once that process is completed, you're going to see another folder. Now, a very important mention is to make sure that you do not have a folder inside of a folder. This can confuse VirtualBox. So make sure when you click on the folder, you see these two files. If you only see a folder inside of here, drag that to your desktop. We can go ahead and delete this zipped up Kali folder. Now for our Windows 10, you're just going to want to run this media creation tool. Click accept. Go ahead and hit create installation media. Next. Leave everything as is here. Next. And then you're going to want to click ISO file. Go ahead and specify your download location. In my case, I'm going to be using my desktop just for organizational purposes. This might take a while, so give it some time. Once that has completed, you're now going to see a Windows ISO. Just go ahead and click finish. From this point, we can now delete our media creation tool, and you should now have these two files. Open back up your VirtualBox, and first, we are going to import Kali Linux. To do that, click open, go to the location where you unzipped the folder, and then you're going to want to import this .vbox file. Now we need to change some settings in here. Right-click it, click settings. First, we're going to go to the system tab, increase your RAM to around 3 gigabytes. Then go to processor, and you can keep it at either 2 or 3. Now you can raise either of these values, but it's unnecessary, since what we will be doing in this tutorial is going to be fairly basic. We do not need that much resources. Now, click the network tab, and make sure the network adapter is enabled. Set attached to internal network, and then you can either specify a name or just leave it default. I'm just going to be leaving it default. Now this is a very important setting because internal network means that we will be creating a logical network for both of these virtual machines. That means when we are running scans from the attacker machine, we won't end up scanning our entire network. Only these two machines will be able to communicate with each other. You can change the VM name if you want. In my case, I'm just going to set it to attacker. Click OK. Now for the Windows host, you're going to want to hit new. You can name this target. You can specify the VM folder or leave it as default. In my case, I'm just going to set it to desktop. For the ISO image, you're going to want to hit this drop down arrow, go to other, go to that download location of where you downloaded your ISO, and then double click that. Now make sure proceed with unattended installation is unchecked. You can go ahead and skip this tab. For the virtual hardware, I recommend setting this to around 4 gigabytes. And the number of CPU cores to around 3 or 4. Windows is a little more resource heavy, so it's important to allocate just a little bit more resources. You can leave the virtual hard disk location as default unless you want to customize that. For the disk size, I'm going to go ahead and change this to 35 gigabytes. What we will be trying to do in this lab is going to be very simple, so we won't be needing much space. Other than that, we are now done with the Windows. Go ahead and hit finish. Now before we go ahead and install our Windows 10 machine, right-click it, Settings, go down to Network, and change this to Bridged Adapter. Now before we set this to an internal network, we're going to need temporary internet access because we have to download Wireshark onto the virtual machine. Once we have downloaded Wireshark, we can switch over to the internal network so that these two machines will be able to communicate with each other. Go ahead and hit OK. Double click your target machine. You're going to see this installation screen pop up once the virtual machine has started. Just hit Next. Install now. Click I do not have a product key. Select Windows 10 Pro. Next. Accept the license terms. Now click Custom. And then Next. Again, this will take some time, around 10 minutes or so just go ahead and sit back and relax. Once it has finished going through that process, go ahead and hit Yes. Yes. Skip. Now, if you decide to use Windows 11 as the target, the only thing that will change is you want to make sure that upon installation of Windows 11, it has no access to the internet. Otherwise, you won't be able to set up an offline account. So for a Windows 11 installation, you would just want to set this to internal network, and then once it is installed, set it back to bridge adapter to complete the steps I'm about to show you. Once you're on this screen, just hit Setup for personal use. Next. And then hit Offline account. Limited experience. Name this PC admin. Next. Set the password as password, but the A is swapped with the @ symbol and the O is swapped with a 0. This is an easy password to remember, and technically this is a very insecure password, but we don't have to worry as this is a simulated environment. Go ahead and hit Next and confirm the password. For the security question, you can just enter in some random numbers. We won't be needing these security questions at all. Just hit Not Now. And then turn all of these off. Hit Accept. Skip. And then Not Now. Once you're in Windows, you should see that Edge has started right up. Go ahead and hit Continue. Start without your data. Uncheck this. Confirm and continue. Continue without Google data. Uncheck this. Confirm and start browsing. Open up a new tab. Type in Wireshark. Go ahead and click this first link right here. And then just go ahead and hit Windows 64 Installer. Now, if for some reason you want an old version of Wireshark, just go ahead and search this up right here. And then you're going to see this right here, all versions Wireshark. Open that page up, and then you'll see that you have all these options for various old builds of Wireshark. Go ahead and go to your File Explorer and Downloads. Run the executable. Hit Yes. Next. Noted. Next. 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 Make sure this is checked. Next. And then install. You're then going to see the npcap setup pop up. Just go ahead and click I agree. Install. Next again. Finish. Just select this. And then power off machine. Okay. Back in VirtualBox, go ahead and right click Target. Settings. Go to Network. And then set the bridge adapter to internal network. This name should be the exact same name on the attacker machine. If it's not, then the two machines won't be on the same network and won't be able to communicate with each other. Go ahead and hit OK. Now we're going to start up our attacker machine. Double click that. After a short period of time, you're going to boot right into Kali Linux without having to go through the installation process. This is because it's a pre-configured image. Both the username and password are Kali. Once you're in Kali Linux, we're going to want to set a static IP address. Go ahead and select Terminal up here. This will open up the terminal. Type in ifconfig. You're going to see that you have your loopback address as 127.0.0.1, and then you're also going to have an IPv6 address. Now this is where the issue comes in. We're going to need to statically assign an IP address to this machine, otherwise our lab won't be able to work correctly. To do this, we're going to use the Network Manager command line interface. So just follow after me. I will also be including these commands down in the description. Once you have typed this in, go ahead and hit enter. Now you're going to want to copy the ID for the wired connection. Go ahead and just highlight this, right click it, and then copy selection. Now you're just going to follow my steps from here. Just to give you guys a deeper explanation of what this command is doing, sudo allows you to run this command with escalated privileges. nmcli is your network manager command line interface. And then you're going to modify the connection, which is your ID that we just copied right here. Then after that, it's going to be your method, which is IPv4, which stands for Internet Protocol version 4. And then the Internet Protocol version 4 address is 192.168.50.10. Now this is a non-routable address, which is perfect for our lab setup. The /24 is the CIDR notation, which stands for classless interdomain routing. But in this video, I'm not going to be explaining that. If you want to learn more about how IP addresses work, as well as classless interdomain routing, I'll be leaving some resources down in the description so you can read more about it. After you have typed out this information, go ahead and hit enter. It's going to prompt you for the password. Just type in Kali. Now that that has completed, we need to set the connection to active. To do that, we're going to type in this. This is basically just saying to turn the connection on. Go ahead and hit enter. You're going to now see that it's successfully activated. To confirm that, go ahead and type in ifconfig. You're now going to see that you have statically assigned your machine with 192.168.50.10, whereas previously you had an automatically assigned IPv6 address, and then either close down your virtual machine or minimize it. We're now going to configure our Windows settings. Go ahead and open up the target machine. You should see no internet access. We're now going to assign an IPv4 address to our Windows machine so that the attacker and the target can communicate with each other. Go ahead and type in Control Panel. Open up Network and Internet, Network and Sharing Center, and then change adapter settings. You're going to see your adapter right here. Go ahead and click Properties. You're going to want to go to the IPv4 tab right here, and then hit Properties. Click the radio button for use the following IP address. We're going to want to type in 192.168.50.20. The first three values are the same as the Kali Linux address. This will essentially make both of these machines on the same subnet. For the masks, once you click on it, it's going to automatically assign 255.255.255.0, which is perfectly fine. For the default gateway, just go ahead and leave this as blank. As well as the DNS server. We don't need this. Go ahead and click OK. Then close. And then you can exit out of all of your tabs. Now we need to ensure connectivity between our machines. On our Windows machine, we're going to start by opening up CMD. And then now we're going to ping our attacker machine. Go ahead and type ping 192.168.50.10. This is the IP address that we set to the Kali Linux machine earlier. Go ahead and hit enter. You're going to see 4 replies from the Kali Linux machine. Now back on our Kali Linux machine, we want to make sure that we can communicate with our Windows host. Open up the terminal. Type in ping 192.168.50.20. This is the IP address that we assigned to our Windows machine. Go ahead and hit enter. Now you're going to notice that it freezes. That's because Windows Firewall by default blocks ICMP packets. So let's go allow that right now. With our Windows machine open, go ahead and exit out of CMD. Hit Windows plus R on your keyboard, which is going to open up this run box. And then you're going to want to type in wf.msc. This will open up your firewall. Go to inbound rules, scroll down, and then just enable these 2 rules right here. File and printer sharing, echo request -ICMP v4 in. Just go ahead and enable both of these. And after you've enabled that, you're going to see that you're going to instantly get replies from the Windows machine. This is because you just allowed the packets through your firewall. Now this is going to endlessly ping the Windows machine, so just go ahead and hit Control-C on your keyboard. This will stop it. I like to keep my terminal clean, so just go ahead and type clear. Now we're going to use our attacker machine to scan our target machine with nmap. In our Kali Linux terminal, type nmap. You'll see the version as well as the website. We're just going to go ahead and start with a simple scan. Type nmap -n. Now -n basically tells nmap to skip over DNS servers because we do not have DNS servers configured with our Windows machine. Then type the IP address of our target, which is 192.168.50.20. Once you hit enter, it's going to say it's starting nmap. Now because our Windows firewall is on, it's going to say that there's 1,000 filtered TCP ports, which is going to be a typical response in a lot of cases. But let's go back to our target machine and let's mess around with some things. Go to the Windows Defender Firewall tab that you have open here, Windows Defender Firewall Properties. And then go ahead and just turn off all of your firewalls. Click apply. Back on the attacker machine, you're going to hit your arrow up key, which is going to bring back the command that we just ran. Go ahead and hit enter. It's going to start nmap and it's going to run the scan again. Now look at that. After we've disabled our firewall, you can now see that there's 3 different ports that are open: 135, 139, and 445. Let's go back to our target machine and turn back on the firewall. Click apply. Now let's go ahead and minimize our firewall, and then we're going to want to open up Wireshark. Once Wireshark is opened, you're just going to want to open up your Ethernet right here. Don't worry about these other adapters that are shown. Just hit Ethernet. Now initially, you're going to notice that there's no information coming in, and as stated before, since we are segmented on an internal network, unless we create traffic, there's not going to be traffic. To create some traffic, type in ping 192.168.50.20. Again, as a reminder, this is your target's IP address. Go ahead and hit enter. Now back on our Windows host, you can see all these different packets that are coming into Wireshark. Now that we've captured some traffic, go ahead and click this red square. This will stop the traffic so we can analyze it. I'm just going to minimize our attacker machine just so I can focus on the Windows machine. We see right here that our attacker machine 192.168.50.10 initially reached out to 192.168.50.20 with an ICMP packet, which was a request. If you go to frame 2, you'll notice that the destination is now the source, and this just continues on. You'll also see an ARP packet, also known as Address Resolution Protocol, asking who has 192.168.50.10. And then you'll see that ARP then responds and says that our attacker machine is at our MAC address right here. This protocol basically allows machines to find each other on a network. Now, an interesting thing to note, if you use this bar right here and scroll over, look at the TTL, also meaning time to live. Now you'll notice for our Linux machine, the TTL is 64, and for our Windows machine, the TTL is 128. The default TTL value for Linux machines is 64. For Windows machines, it's 128. So this is one way you can identify an operating system. Regarding any other information in the packets, like these different fields down here, I won't be explaining them in this video, as that's kind of going off topic. But if you guys want me to make a separate video on explaining what these fields mean, then just let me know in the comments. Anyways, let's hop back to our attacker machine and just go ahead and stop the ping. Just hit Ctrl+C. Back on our Windows host, let's start a new capture. Hit File, and then go to Close. Just click Continue without saving. Open up Ethernet again. You're going to notice that there's no packets. So let's make some more traffic. But this time, we're going to do it a little bit differently. Back on our attacker machine, just type in nmap-n 192.168.50.20. Let's go ahead and run this. If you go back to your Windows host, you're going to notice a ton of packets come flying in. These are all TCP. This is the result of the nmap scan we're doing on our attacker machine. Now that the scan has completed, you'll notice that 2,002 packets were created just off of that one scan. Let's just highlight one of these packets. We're going to do frame 3. If we go down to Transmission Control Protocol, take note that the source port on our attacker machine was 54,577, and our destination port was 995. Now, one thing that I want you to take note of is look at all of these destination ports. They are all different. Now, the reason being is because nmap is trying to scan all of these ports to see if it gets a response. Notice how they are all SYN. That's because our target is not responding back to any of these SYN requests. And that is because our firewall is enabled and filtering these ports. Now let's go ahead and turn off the firewall and try this again. Go back to your Windows firewall, Windows Defender Firewall Properties, and then just turn all of them off. Click Apply. Just go ahead and hit Stop Capturing Packets, and then close. Continue without saving. We're going to open up a new capture. Double click on Ethernet again. Now let's create some more traffic. This time, since our firewall is off, let's see what happens. Go ahead and just click your up arrow key back on your attacker machine. You'll now notice a ton of packets say RST ACK. That's because nmap is sending a request, but our machine is returning a reset ACK because there's no connection to be made. Let's take a look at frame 6. You'll see that our Linux machine tried to connect on port 445. Now if we scroll down, and we click on frame 16, our target machine responded with SYN ACK. This means that a connection can be made. You can just see how noisy this nmap scan was. It created 2,075 packets. Now there is other nmap scans that are a lot less noisy, but we will not be going over those in this video. Once again, if you guys want me to make another video on all the various different types of nmap scans you can run, just let me know down in the comments. But anyways, that about concludes our simple penetration testing lab. We can just go ahead and quit out of everything and close down our virtual machines. If you guys enjoyed this video or found it helpful, consider liking and subscribing. And I know I've said this a million times, but if you guys want to see any other videos, just let me know down in the comments. I will be making tutorials on just about everything. I hope you all have a great day, and I'll see you all in the next one. Peace.